I shouldn't put that as equal to, just to be on the safe side. I need to make sure that that is not, it's not 3 over x to the power of negative half, because that would flip things and then we'd get all, so we're just going to keep that as 1/2. But when we say it, when we bring it out and we say n is equal to, we're going to say n is equal to negative 1/2 because it is on the bottom. Okay, so now we're pretty much set up. Now we can say n is equal to negative 1/2 and n plus 1 is equal to half. So now I can do my things, and again remembering that I'm going to do in my general form ax n plus 1 over n plus 1. So what is my n plus 1? It's 1/2. So I'm going to have this is something that we didn't talk about, yes. We can bring any constant out front. Anytime we have a number that's a constant, and in this case that 3 is going to be a constant because we can say that it's the coefficient. We can really rewrite this thing as we could rewrite it like that, just to be, to get it all out there. So now I can bring this, any coefficient, I can bring that out as a constant, and then I've got, and that's why they've done that here, because I can bring that 3 out front, and then I've got, as you were, that's ugly. And then I've got x to the power of negative 1/2. Now we can integrate, and we've still got that as n plus 1 is equal to that. So now when I integrate it, I can say 3 times, and then whatever this is going to be, and this is going to be x to the power of 1/2 over 1/2, okay, plus c. Now I can clean this up and I can say, so 3 times, that's x over 1/2. That's really the same as saying 3 times 2, because if I multiply by the denominator being a fraction, that's the same as flipping that. Okay, so 3 times 1/2, or 3 times 1 over 1/2, is the same as saying 3 times, let's see, that's 3 times 1 over 1/2. Now remember, when we can flip these, it's the same, when I have a division problem in the bottom, that's the same as saying 1 times 2 over 1. So that's where we get 3 times 2 is equal to 6. And so that's where I'm going to get 6. I'm going to get that 6 because I'm dividing by a fraction, and that's the same as multiplying it. Okay. Multiplying, so this whole thing is the same as saying 1 times 2 over 1. Okay? Because that's basically saying 1 divided by 1/2, or we can flip it and say 1 times 2 over 1. So that's where I get my 6. And I still have my x to the half. And then I still have my plus c. Okay? So if I just wanted to clean that up, I can say 6 square root of x plus c. Okay? That's worked example number 5c. And then now I'm going, here we go, come on. The integral of, now I've got two things here. Don't forget the dx. Now I don't know how to integrate these things separately. So what I do know how to do is I know how to I do know how to expand this and make this all into one nice equation. So I can basically multiply that out. And so I get 3x squared, that's the first, x times 5, and that's negative 3x. So 5x minus 3x is going to be 2x. That's the x's, and then my last term is going to be minus 5, and then dx. Now I can integrate this because I know what I'm doing. So in this case, the first one n is going to be 2, and then I'm going to also have n is equal to 1. So I'm going to use that n is equal to 2, and I need to use that n plus 1 is equal to 3, and in the second case, n plus 1 is equal to 2. So the first case right here, I'm going to use that with that. So I need to take that to n plus 1, so that's 3x. N plus 1 is 3, but that's also divided by n plus 1, which is 3. So these two cancel out, and I just get x cubed. Plus, now in this case, like I said, that n plus 1 is equal to 2. So I'm going to do 2x, n plus 1 is 2, divided by n plus 1 is 2. These cancel out, and that's x squared minus, and then I'm going to go 5, and then I'm going to say, now in this case, sorry, n is equal to 0, because I don't even have an x, so that's going to be 5x. Okay? And then I can clean this up, and I get x cubed plus x squared minus 5x. And that's the original equation. Now, just to check, if I wanted to, I could differentiate this equation, and I should end up with something that would look like that. Okay? Okay.